So the power of the replica set is, to keep it simple, you can manage multiple copies of a pod, so-called replicas. So you declare a replica set, and you can arbitrarily horizontally scale your web application by creating more and more instances of it, by creating more pods. Therefore, you specify a pod template, because the pods will actually be created from the replica set. You can also see that you have a simple self-healing behavior, as when pods are deleted, the pods will be recreated. But we've also seen, and that is a very important fact to recognize, that whenever pods are created or recreated, that their names will change. As we will see later in the chapter of stateful sets, this would be undesirable behavior in the context of stateful applications such as databases. So replica sets are suited for stateless applications, or applications with lightweight state. I personally think applications should not have a state, but they should pass state either to a data service such as a database or a message queue, or an object store, and not store anything permanently and persistent in a local disk. While you can attach volumes and also persistent volumes to pods and replica sets, I strongly advise not to do it. So either go with a stateful set or use a backing service. The only exception to this rule, in my opinion, and this is an opinion, it's not something that is beyond discussion. There are other developers seeing this, or with very different opinions about this. But my opinion is, unless you have a legacy application, a legacy application to me is an application that has been developed at some point, and the developers are either not present anymore, or they left the company. Well, most likely developers are still in the company, but the project does not have any more budget. So the source code is maybe in maintenance mode, and the source code has dependencies to the file system, for example, and therefore has a certain state. And in order to get the application into a Kubernetes without modifying it too much, because it wouldn't be worth it, you'll get a bit free lunch by adding it to Kubernetes. You'll get a bit of the self-healing advantages. You don't need so much of the scaling. Well, in this case, it could be fine and fair enough to also have a stateful set or pods with a persistent disk. But beside of that, the application should be stateless, and that's a good application for replica sets, when the applications are stateless. All right, so the point here is that the replica sets pods, they do not have a stable network identity. So whenever the pods are recreated, the IP address change, and also the internal host names of the pods change, which is a problem because, for example, if you do a microservice application, and you'd have one service that depends on another, and they will need, let's say, an HTTP REST API interaction, then you need to somehow tell the application A where to find the application B. And therefore you need a stable network identity, which the pod doesn't provide you, which also the replica set doesn't provide. For this reason, we go back to the tutorial, and we'll now create a simple web application from within the cluster, and first look into how the pods are created, and then we'll also show how services can be used to provide the pods and the replica set a stable network identity. So straightforward access to the web app is directly to access the corresponding pod. So in this case, we'll have 4 replica sets. We don't need them. So let's reduce it back to 1, which will be good enough for our example at the moment. We'll apply it. While we apply it, you can see it's already done. Pods have been terminated. All right, we are back to 1. Get the pods. You can see that 3 of them are terminating, so we choose this one. All right, so you can see that the pod itself has an IP address. The IP address is an internal IP address within the Kubernetes cluster. Per default, and this can be changed with additional plugins, per default, the Kubernetes cluster has a flat network topology, which means that there is one IP address namespace, and all the pods and services, well, at least those who have IP addresses, will receive IP addresses from that namespace. And there, on the network level, it is possible that each network client, for example, 2 different pods, can talk to each other. In real-world clusters and production-grade clusters, you may want to have additional security plugins to restrict the access by using firewall rules that will restrict the communication to those paths that are explicitly allowed. So it would be a whitelisting instead of a blacklisting or an allow all like it is per default. So let's take note, there's an IP address that we can use, and let's take it from here. So we are now starting an interactive container. So we are going back to the container shell access, and we could use this one. I'm just asking myself, maybe I could go to the stateful set part, because there is another container image, this one. So this is also an interactive container. I've created a little container image. It's called inspect. It is using the inspect. I may have to add a version here. All right, 1.3. We'll do the trick. All right. What this does is it takes this little container image. It's actually not so little, because it's basically a Ubuntu container image. And I added some packages to the image that help me to debug and demonstrate certain things in the tutorial. So, for example, it also gives me a bash instead of an ordinary shell, which is more comfortable. So here we are within the container. So we are within the container. We've extracted the IP address from the pod, which would be this one. So we can, for example, try to ping it. Oh, ping is not there. You can do a reverse lookup. but maybe we can do a curl. And as you can see, we are here on a different pod. You can also look at the outside version. Here's our inspect pod. And this is the IP address of the inspect pod. So we are here in the inspect pod, and we are now curling to the ReplicaSets pod, to the web service on port 8080. And you can see you can do that. So what this means is that you can reach a pod with its open ports from other pods without a restriction. The problem with this approach is that when we kill the pod, or the pod is, it has failed for other reasons, and the replica set will self-heal, it will create another pod. So you can see it has created a new pod, but when I curl, it may still be terminating. Yes, it's still terminating. We have to wait for the termination to be completed. So now when the pod is gone, although the replica set has self-healed by creating another pod, the new pod has a new network identity. In this case, a new IP address. And therefore, like referring to a pod by IP address is a poor idea. So a takeaway here is the replica set brings self-healing. Self-healing means that a failed pod is being recreated. During recreation, the pod will change its IP address, and therefore using IP addresses to refer from one pod to another is an anti-pattern. It doesn't work because for this reason. IP addresses will change, and if they change, the connection to the other service would be lost. This is not desirable. So there's a way on how you can provide a stable network identity for a pod or replica sets pods. And we'll look into how this works. Okay. A note on the pod and pods and ports. We have one container in the pod. This container creates or starts a process that binds to port 8080. So there's, 65,535 different ports, theoretically, and we've just used one of them. Now, because all the containers in a pod share the same network device, if you open a port within a container, you basically block that port within the pod. Well, so this means that if you open up 8080, another container in the same pod could also use and access the web service on port 8080, but it cannot create another service on port 8080 because port 8080 is also already occupied. So you have the full range. Of ports available for the pod, but the containers have to be organized in a way that only one container uses one particular port at a time. Well, at least binding to the port at a time. You can use an open port like from all containers, but you can only bind to that port once per pod. Now, if you have two pods that have port 8080, for example, like we did before, and had two replicas, this is not a problem because each pod has its own internal IP address, and with its own internal IP address, it may also open the full range of ports. So having two pods both opening port 8080 is not a problem, but having two containers within a pod opening port 8080 would be a problem. Takeaway: you can have arbitrary ports on a pod. You can have two pods with the same port opened and bound to it, but you cannot have two containers binding to the same port in a pod.